All right, so for our topic 2 video, I'm just going to start right into talking about the unit circle again. I've given us a nice fresh copy since I scribbled all over our last one. So let's talk about the unit circle and how it relates to sine and to cosine. So I'm just going to write up here sine, of an angle, and actually I'm going to begin using theta. I mentioned that in class. We often talk about angles using the Greek letter theta. So in this section, I'm going to try not to scare anybody with Greek letters. I think it's kind of cool. Nice little swirly O. And so this is sine of theta and cosine of theta, and we're going to talk about what they mean. First, before we define it, I want to talk about how any angle along this unit circle, we talked in the last section a little bit more about angles as they relate to a line, like as if it's a clock. So this line would be, I don't know, maybe about 30 degrees above the starting point, and so we'd say this angle represents 30 degrees. But I also want you to think about the fact that there's this point here on the end of like the clock hand that travels around and around the circle as we open that angle. So let's say I open the angle past 30 degrees and I open it up to 90 degrees. That hand with that point on the tip would move here to 90 degrees. And that point will travel, it will continue to be a distance of 1 from the center, of course, because it's a circle, and will travel around and around and around. So that point is really the most important part about how we define sine and cosine, and here's why. Any point along this circle could be described as, yes, being a radius of 1 from the center, but it could also be described using an xy point. So any point along this circle can have an xy component to it. And it doesn't matter if it's here in what we call the first quadrant of the coordinate plane, or if it's, some point over here, right? That would still have an xy coordinate that could describe it. Oh no, hiccuping pen again. Or some point over here in this section, it would still have an xy coordinate, and so on and so forth. So anywhere that I open this angle as the clock hand opens around and around, goes around the clock, we could think about the tip of that hand as moving along like a racetrack around and around the circle, and each place that it stops, we have an x and a y coordinate that we could describe it. So let's talk, let me get another color here. Let's talk about some points that we know really well. So we'll do 90 degrees again. We'll call this 0 degrees again. 180. And this is 270. Whoop. Oh my goodness, just draw a circle. Okay. 0, 90, 180, and 270. At 90 degrees, this point is at a very easily identifiable location as far as the xy components. In fact, I've listed it here. This is the point 0, 1. And how do I know that? Well, I know it because it's straight up and down above the origin, and it's on a circle with a radius of 1. So it has to be 0 units in the x direction and 1 unit up in the y direction. So 90 degrees, we call that 0 and 1. 180 degrees, very similar, except I'm -1 in the x direction and 0 in the y direction. And for 270 degrees, I could say it is 0 units in the x direction, -1 in the y, and then back to 0, or we could call it 360. This is 1 unit in the x direction and 0 in the y. Now, if you have your calculator, I would recommend, just to kind of test this out, take 90 degrees and, pause the video for a second and take the sine of 90 degrees, press enter, and then say the cosine of 90 degrees and press enter. So I'm going to keep talking just in case some people don't have their calculator, but if you do, just pause it, find those values, and then do the same for 180. Find sine and cosine for 180. Then go ahead and find sine and cosine of 270, and then find sine and cosine of 0 degrees. So take a second, pause the video, and do that. Write it down, and check to see where you might see some correlation between sine and cosine and these angles. Now I'm going to continue because I don't want to pause myself. Hopefully you really are pausing and doing this with me because it's way more fun. But let's say we have sine and cosine for these angles. If you plug into your calculator the sine of 0 degrees, you should get an answer of 0. And if you plug in the cosine of 0 degrees, you should get 1. If you do the same thing for 90 degrees, you should find that the sine is equal to 1 and the cosine is equal to 0. If you do this for 180 degrees, you should find that the sine of 180 degrees is 0 and the cosine is -1. Hopefully by now you're starting to see a pattern emerge. And then if you do it for 270 degrees, you're going to find that the sine of 270 degrees is -1 and cosine is 0. Now, if you take these values and you compare it to the xy coordinate, you're going to find that the sine every time identifies the y coordinate. So the value of sine and the y value of a coordinate is exactly the same, and that is intentional. The cosine for each one of these values matches the x coordinate. And again, that is intentional. At each one, for each angle, when you put it into your calculator, cosine of 0 degrees, you get 1. That's because the x value at 0 degrees is 1. So there is a direct correlation. In fact, the way that we define sine is as the y coordinate of any point on a unit circle. And the definition of cosine is the x coordinate for any point along a unit circle. That is the definition of sine and the definition of cosine. And that's going to work for any point. So let's say, if you have your calculator still out, go ahead and try it for 45 degrees. So take sine and cosine of 45 degrees. And what you're going to find is that you get a value of about 0.707. It keeps going. It's a nice decimal that never ends. And you get it for both the x and the y. So the cosine, which remember is the x value, is 0.707. And if we take the sine of 45 degrees, we get the y value. We're also going to get 0.707. And I want you to think, does that make sense? If I'm defining the x and the sine and the cosine as the y and the x coordinate for this point at 45 degrees, does it make sense that this point has an x and a y? I'm going to draw it like this. We're used to talking about x and y as how far right, left, and how far up, down. So does it make sense that the x and the y has the same value at 45 degrees? And if you think about it, yeah, it does, because 45 is it's halfway between the x-axis and the y-axis, so it makes sense that it's going to be a mirror image. X and y coordinates are going to be the same. It also makes sense that both of these values are less than 1, because if you think about it, these coordinates are never going to be farther away from the origin than 1, because the radius of the circle is 1. And it also should make sense to you that the value for 45 degrees, that the x and the y coordinate are both positive, because 45 degrees exists in a part of the unit circle where the x and the y should be positive. Just in case you're not sure where I'm going with that, let me apply this over in this other quadrant. Think about 0 degrees, halfway to 90 is 45, and then we have 90, then halfway to 180 degrees, that's right about here. That's 135 degrees is halfway between 90 and 180. You can check me on that if you don't believe me, but 135 is halfway. So again, go ahead and go find the sine of 135 and the cosine. And what you should find out is that the cosine of 135 is going to give you the x coordinate. And the sine of 135, I wish this wouldn't do this, of 135 will give you the y coordinate. Cosine of 135, sine of 135. Now these numbers that you're getting in your calculator should look familiar. The cosine value is going to be approximately negative 0.707. That sounds familiar. That's about where the 45, the midway between 0 and 90, that's what that, except it's negative. Think about why that might be important. And then the sine is going to give you a positive 0.707. $135 is halfway between 90 and 180. 45 is halfway between 0 and 90. Does it make sense that the x and y coordinates are kind of symmetric to each other like this? Except you might ask, why is this one negative? Well, isn't it true that over in this quadrant, the x coordinate should be negative because it's negative 0.707, and the y should be positive 0.707. That should sound just about right. And again, it's less than 1 because the point on this circle should never be further away from the center than 1, and as it travels around and around with a radius of 1. And but yes, in this case, the cosine is going to give us an x value that's negative, and the sine is going to give us a y value that's positive. Okay, I'm going to leave it here because I think there's a lot more that we could discuss in class as we're practicing and we're seeing how these definitions of sine and cosine using the unit circle relate to the coordinate system and all these fun things that we have to look forward to. But here's the bottom line. I do want you to have all of these notes so that we can talk about them, but if you were to boil it down to one important detail, or I guess two important details, it's this. The sine of an angle will always give you the y coordinate for that point on the unit circle. And the cosine of any angle will always give you the x value for that point on the unit circle. So sine is y, cosine is x, and it works for any degree. It doesn't matter if it's between 0 and 360, or if it's greater than 360, or if it's less than 0, if we can put in a negative angle. In fact, if you wanted to, you could practice, you could use the example that we had in the first topic video, and you could compare what happens if I say sine of 40 degrees versus sine of 400 degrees. Remember, we talked in the last section, 40 and 400 are coterminal angles because they both land on the same part of the unit circle. Well, check out what happens if you take the sine of 400 and sine of 40. You might expect if they're coterminal, they should have the same value, and that's true. You'll put it in your calculator and you'll get the same value. So this is, as my picture disappears on me, we're going to call this the end of our video, and in class tomorrow we will talk about how this expands to some practice problems, how we can practice sketching angles inside of a unit circle, how we can predict what the sine and the cosine values are going to be, and all kinds of awesome stuff. So that's what you have to look forward to tomorrow.